Hello there. Are you a researcher? Most likely you are. For a time period, imagine being a novice researcher in the research area of biomedicine, and you're trying to look up for new problems. Let's say you're interested in finding out new medicinal properties for diabetes. So what is your first step? The first step is to try and go and look up into the literature. At this point, if you try and Google for diabetes mellitus, you get more than 23 million references. Well, this is a disaster because you don't really know where exactly to start from. Only if there is an automated way that could find novel research problems for you. Well, hypothesis generation, a subcomponent of biomedical text mining, precisely does that. So, given two topics of interest, let's say Alzheimer's and medicine, the problem of hypothesis generation tries and find out the implicit terms that connect them in a novel way. So in this example, the V terms that would connect these two disjoint terms are known as conceptual bridges, because they're trying to bridge these two disjoint terms together. This is sort of a general pipeline for hypothesis generation. So you first have a corpus. From that corpus, you try and find out relevant entities. Using those relevant entities, you create a knowledge base. And you sort of reason upon this knowledge base and generate novel hypotheses. So what is the limitation of the previous studies? Well, most of the previous studies, they try and model this problem in a graph-based approach. But one of the problems of these existing approaches is that they only find those terms which are in their route. What about radical links? What about surprising links? In order to take into account these radical links, we try and model in a word embedding based approach. Well, what are word embeddings? Word embeddings are dense, low-dimensional vectors, and the distance between these terms in the Euclidean space denotes their semantic proximity. So what's new in our approach? We try and leverage the temporal component of the corpus and generate temporally charged word vectors. So the question comes, why is the need to leverage temporal component? So let's take this as an example. So in this example, the term cell initially was associated with terms such as prison, cottage, and cave. Most lately, and during 1900s, this came to be associated with terms such as membrane and epithelial. Well, what does this tell us? This tells us that the semantic meaning of a concept changes over the period of time. And our intuition is, if you can model the semantic evolution over the period of time, we can find novel links. So let's take this as an example. In this figure, the term Vishrawas and Raynaud's disease, they were very distant during 1950s. However, over the period of time, the semantics got closer and closer. And finally, during 1980s, this sort of came together and formed a link. So this is the problem that we try and address in this particular study. For more information, please refer to our paper and come in our poster session. Thank you.